Assalamualaikum, my name is Hariz Amsyar bin Zulkifli, and today I will present to you my final year project presentation, which is the road accident prediction using artificial neural network. Every year, the lives of approximately 1.3 million people are cut short as a result of a road traffic crash. Between 20 and 50 million more people suffer from non-fatal injuries, with many incurring a disability as a result of their injury. Road traffic injuries cause considerable economic losses to individuals, their families, and to nations as a whole. These losses arise from the cost of treatment as well as lost productivity for those killed or disabled by the injuries and for family members who need to take time off work or school to take care of the injured. Road traffic crashes cost most countries 3% of their gross domestic product, according to the World Health Organization in 2021. The number of road accidents in Malaysia has increased during the last 10 years, according to Figure 1. Meanwhile, the number of fatalities has been a steady reduction from peak at 7152 in 2016 and showed the lowest number at 6167 in 2019 during the last 10 years, in Figure 2. Now we move on to the problem statement. A published data reveals that since 1997, there is a steady increase of the number of registered vehicles in Malaysia at an annual rate of 7%. With the increase of vehicles on Malaysian road, the number of road traffic accidents demonstrates a steady increase as well. At an average rate of 5% per year, more than 500,000 road crashes were recorded in 2017 on Malaysian road. In Malaysia, recent statistics show that there are nearly 24 deaths per 100,000 people for all road users. Expressways are potential sites of fatal highway accidents in Malaysia. Better accident severity prediction models are critical to enhancing the safety performance of road traffic systems. After finishing the background study and problem statement, now we can ask ourselves what are the research questions that we want to answer. There are three. The first one, what are the variables affecting the road traffic accidents, how to design a road traffic accident prediction model using ANN, and how to develop a road traffic accident prediction model using ANN. After asking ourselves the research question, we can now develop the objective of the research, which is to identify the variables affecting road traffic accidents, to design a road traffic accident prediction model using ANN, and to develop a road traffic accident prediction model using ANN. After developing the research question and objective, we can now define the scope of the research. The first one is that the dataset used is all provided from open data gathered from the Malaysian government dataset, which is the data.gov.my. The second one is that the technique will be applied to the model is artificial neural network. And the third and final one is that the range of the dataset is around the year 2010 to 2019. After all that, we can ask ourselves the research significance. Well, the result of the prediction model may help government bodies such as the Malaysian Institute of Road Safety, MIROS, or the Royal Malaysian Police RMP to understand the factors that lead to road accidents. From there, we can improve road user education and also enforce existing law and regulations. Now we move on to the second chapter, which is the literature review. It encapsulates all the background study that we will use to further understand the topic, such as the technique, domain, and related works. My topic is the traffic accident prediction using artificial neural network, and the domain it uses is transportation. Some of the techniques used for traffic accident predictions are using convolutional neural network CNN, artificial neural network ANN, and recurrent neural network RNN. And here are some of the related works, either the same domain with different techniques, such as the severity prediction of traffic accidents with RNN, text-based delay prediction in a public transport monitoring system, predicting serious injuries due to road traffic accidents in Malaysia by means of ANN, and also machine learning aided simulation of public transport utilization. And here are some of the related work with different domain with same technique, which is using the prediction of rainfall using ANN, application of artificial neural network for prediction of marine diesel engine performance, and optimized ANN ABC for thunderstorm prediction. Now we move on to the relevant works that are related to traffic accident prediction. The first one uses multiple input single output A and N, which results in a 95% accuracy. The second one uses a recurrent neural network, which is best for time series data, and it uses LSTM or long short-term memory to solve its vanishing gradients problem, but it only results in a 71.77% accuracy. And finally, the k-means and random forest technique used in the final title shows that the k-means only shows a 35.83% accuracy and random forest shows a 99.86% accuracy. However, it is easy for the random forest to get a high accuracy, but it has its own downside, such as being too slow to use in real time. The final chapter is the methodology. It uses objectives from the previous chapters to identify phases and activities that we can show our results to in the form of deliverables. The first objective is to identify the factors that affect road traffic accidents, and in this phase, we do project planning and preliminary studies. And the activity that we do is discuss it with our project supervisor, identifying problems related to the topic, and also background study. From there, we can develop our own problem statement, research objective, research scope, and project significance. Then, the next phase is knowledge acquisition and analysis. From there, we can research our road traffic accident prediction methods that we want to use. And our result will be a literature review on methods used to predict road traffic accidents. From the same objective, we can move on to the phase of data collection by collecting data from the Malaysian government database to acquire the raw road traffic dataset. From there, we can try to understand the data by analyzing it to gain the knowledge of the dataset. Finally, we can do data processing by data cleaning to replace any missing values, extreme values, outliers, and noise, or any relevant methods to data clean it to ensure we get a clean road traffic dataset. The final objective of the methodology is to design and develop a traffic accident prediction using artificial neural network. The phases include model design, which is to design the architecture and the flow of the model, and model development, which is to develop a prediction model using artificial neural network. And then we move on to testing and evaluation. We test and evaluate and maybe do some tweaking to get a better result. And finally, we do a documentation, which is finally writing a report and final report in the appropriate format. Thank you very much.